The information on this concentration, we will use in the dilution and also chemical reaction process. So the dilution is the process of preparing the less concentrated solution from the more concentrated one. How to produce the less concentrated one or the dilute one is by adding solvent. However, we have to remember that the number of mole or the amount of the solute before the dilution will be the same as the amount of the solute after the dilution. And the amount is expressed in mole. So since that mole before is equal to mole after, and initial is equal to n after, and we know that mole is equal to molarity multiply with the volume. By using, when we apply this formula in molarity is actually mole over V. And then we mix mole as a subject, so the mole is equal to molarity multiply with V. So that when we said that the N1 mole initial is equal to mole final, it means that M1 V1 or the initial mole that we got from the multiplication of the molarity and also its volume is equal to the N final, which is equal to the new concentration multiplied with the new volume. Look at to the example. How much the volume of the copper sulfate that is needed to prepare 250 ml of 0.1 molar of the copper sulfate. The stock solution concentration is 1 molar. We have to know that the stock solution means that the concentrated solution. Stock means concentrate. 250 0.1 molar, this is V final, this is M final. This is what we want to produce, and then 1 molar is M initial. So what the question want is V initial. So use a formula M1 V1 equal to M2 V2. We want to know V1, make it as a subject. It is equal to M2 V2 over M1 equal to 0.1 molar multiply with 0.25 liter over 1 molar. So that we will get the volume of the copper sulfate that is needed is equal to 0.025 liter, which is equal to 25 ml. This is how we apply the dilution equation, the dilution formula. The next process that will apply the concentration unit is the reaction. And the reaction, one of the reaction methods is by applying titration technique. So this is the process of reacting a solution with the unknown concentration with another one solution that we know their concentration, or what we call as a standard solution. It can be conducted for all three types of a reaction that we have learned. Either by using acid-base, precipitation, or redox reaction. So when we do a titration, they will be equivalent point, and this equivalent point is a point which the reaction is completed, based on the mole ratio. If let's say we have a reaction between acid and base, HCl, that is reacted with the sodium hydroxide, it will produce NaCl and also H2O. We know that their ratio is 1 to 1 to 1 to 1. So that if let's say I have 0.3 mole of HCl, the equivalent point will reach when I've added 0.3 mole of sodium hydroxide, okay, in the titration process. The equivalent point is reached when we add the enough of actual amount that is needed for the complete reaction to occur. However, if we have other reaction that their ratio are different, for example, if I have HCl that is reacted with the MgOH2 to produce MgCl2 plus with H2O. So 2HCl, 2H2O. So if I have 0.6 mole of HCl, the equivalent point will be reached when 0.3 of the magnesium has been added to the titration vessel. Okay, this is because their ratio is 2 to 1. When we do a titration, okay, normally we will use indicator, which is a dice, okay, that will determine the end point of a reaction by the permanently color of the solution change. So in general, for a reaction, okay, we have A that is reacted with B to produce C plus D. A, B, C and D are their stoichiometric coefficient. Okay, so that the equation that we will use to solve this type of problem will be MAVA over MBVB equal to A over B. MA is the concentration of the first reactant. V is the volume of the first reactant over MB is the concentration of the second reactant. VB is the volume of the second reactant. This A is the coefficient of A and B is the coefficient of the second reactant B. So let's look at to the example. Here, how many ml of the HCl that is needed to completely neutralize barium hydroxide. So to answer this question, okay, firstly we have to have the complete and balanced equation. So the balance equation is given here. 2HCl react with the barium hydroxide, produce barium chloride and 2H2O. So their ratio is 1 to 2. Take out all the information that we have. Here we have 0.155 molar of HCl, 35 ml, 0.101 molar of barium hydroxide. So write the information that we have. Molarity is 0.155. Volume is what we want to calculate. Molarity of barium hydroxide is 0.101 and volume is 0.035 liter. We want to calculate the volume. So we know that this is a reaction. This is not the dilution process. So we will use the equation of MAVA over MBVB equal to A over B. So this time I choose my A to be HCl, so that it will be MHCl VHCl over MBaOH2 VBaOH2 is equal to, their coefficient is 2 and 1. Okay, so since that we want to calculate what is the V of HCl, so make it as the subject. So VHCl is equal to 2 multiply with the molarity of the barium hydroxide 0.101 molar, multiply with the volume of the barium hydroxide 0.035 liter over 1 multiply with the molarity or the concentration of the HCl 0.155 molar. Okay, so that when we press the calculator, we will get the volume of the HCl will be 0.0456 liter. In the test or exam, one will be unknown. Okay, it's either the molarity of one reactant is unknown, volume of it is given, volume of the second reactant given, and molarity of the second reactant given, or anyone that will be unknown. Okay, and there are sometimes question that will be given to you and when a mole of one reactant is given. So we know that mole, consider molarity multiply with its volume. This is the example of the redox reaction. Okay, as usual, when we got a question, okay, we have to read it and identify whether this is a dilution or reaction process. So since that we have a KMnO4 oxidized iron sulfate, we know that this is a reaction. Okay, then take out the information that we have, 16.5 ml. Okay, and the concentration is 0.1327. As for the iron sulfate, we only have a volume of it. And then the equation is given. Okay, in this case, the ratio between iron and also MnO4 minus is 5:1. Okay, so write the information that we have, volume and also the concentration. For iron, we have 0.02 liter. Concentration unknown. MnO4 minus, volume is 0.0165 liter. And the concentration is 0.1327. Okay, so we have to calculate the concentration of the iron sulfate solution. So we will use the MAVA equation. Okay, so in this case, I will take iron as my A, so that MFE2 plus multiply with VFE2 plus over MnO4 minus MnO4 minus is equal to 5/1. Okay, so makes molarity of the iron as a subject. So MFE2 plus is equal to 5 multiply with molarity 0.1327 molar multiply with 0.0165 liter over 1 multiply with 0.02 liter. Okay, we can cut liter with liter. And when we press the calculator, we'll get the answer 0.547 molar. With this question, I end this chapter 2. Okay, so this is a higher level of question. Okay, please try to apply all the information that we have discussed before. Okay, and answer this question. Okay, so with this, we have finished chapter 2. Okay, and you can start to complete your tutorial 2.